Your electricity bill is about to go up, not because of inflation, not because of your habits, because of a machine you have never touched running 24 hours a day in a building you will never see, and nobody is telling you this. In the next 10 minutes, you are going to understand something that the conversation about AI is completely missing. Everyone is talking about what AI can do. Nobody is talking about what AI costs in electricity and money, and in consequences that land directly on you. By the time this video ends, you will understand why the biggest constraint on AI is not intelligence. It is power. In 2017, only a small fraction of global data center servers were built for AI workloads. By 2030, that share is projected to exceed 20%. That sounds like a technical statistic. It is not. AI data centers run massive arrays of GPUs around the clock. Unlike conventional servers, they never sleep. They require advanced cooling systems, constant power, and infrastructure that consumes electricity at a scale that has no historical precedent. By the end of this decade, AI data centers could consume double the electricity they consume today. In the United States alone, nearly 10% of all electricity could go to data centers. 10%. That is not a rounding error. That is a structural shift in how electricity is distributed and who pays for it. But before we get to what this means for your bill, you need to understand how we got here. In late 2022, ChatGPT launched, 1 million users in 5 days, the fastest product adoption in the history of technology. What followed was not just a software revolution, it was a physical one. Hundreds of billions of dollars began pouring into physical infrastructure. Amazon announced $200 billion in capital expenditure for 2026 alone. Alphabet committed $180 billion. Microsoft $155 billion. These are not software budgets. This is concrete, steel, cooling towers, power substations. The global data center lease market ballooned to over $700 billion. That is a 340% increase in just 2 years. And here is what the financial analysts are quietly saying behind closed doors. The productivity gains that were supposed to justify this spending have not yet appeared in GDP figures. The UK poured billions into positioning itself as an AI hub. In January 2026, UK GDP growth came in at 0.0. Investigations revealed that many sovereign AI data center projects were not operational facilities, they were scaffolding yards. Empty sites with announced names and unspent promises. Now, this does not mean AI is a fraud. It means the physical infrastructure required to run it is arriving faster than the economic framework to sustain it. And the people who will feel that gap first are not the companies building these systems. They are the people paying electricity bills. But here's where the story gets significantly more complicated. Right now, there is a war being fought over the machines that make AI possible. Not a war of ideas, a war of chips. NVIDIA's data center revenue grew 17 times between 2021 and 2025. 17 times, in 4 years. The United States Department of Justice has issued subpoenas investigating whether NVIDIA used what lawyers are calling loyalty penalties mechanisms designed to prevent customers from buying chips from anyone else. Meanwhile, the US government has sent a message to foreign nations that is almost unprecedented in its directness. AI chips will remain in America unless foreign governments invest significantly in US-based manufacturing. This is not trade policy. This is infrastructure control. The country that controls the chips controls the intelligence, and the country that controls the intelligence controls what the future looks like. But there is a physical dimension to this that almost nobody is covering. Iranian drone strikes recently affected helium supplies from Qatar. Helium is a critical component in advanced semiconductor manufacturing. The Stargate project, a $500 billion infrastructure gamble to secure American AI leadership, is not just a financial bet. It is subject to the same physical and geopolitical constraints as oil pipelines and shipping lanes. Now there is a solution being built right now that could change this entire equation. NVIDIA has unveiled its next architecture called Rubin, named after astronomer Vera Rubin, built on Taiwan Semiconductor's 1.6 nanometer process. The numbers are difficult to comprehend. 10 times lower cost per token compared to the current generation. 384 gigabytes of memory per GPU, 3.6 terabytes per second of bandwidth. And training that previously required a full data center now requires 4 times fewer GPUs. This means the energy crisis in AI could theoretically begin to resolve itself by 2027. Theoretically, because here's what the Rubin architecture cannot fix. The $200 billion already committed to building infrastructure for the current generation of chips, that infrastructure exists. It is being built right now. It will consume electricity for decades. And somebody has to pay for it. Here is the number that no AI company has put in a press release. By 2030, AI data centers in the United States alone could consume as much electricity as the entire country of Japan. Japan, a nation of 125 million people, consumed by machines running language models. Now you might be thinking data centers are a private industry problem. Companies will pay their own electricity bills. This is the part that almost nobody explains. They will not. Data centers negotiate directly with local governments and utility providers for subsidized electricity rates. Investigations into multiple US states and UK regions have revealed that councils approved data center projects despite environmental warnings specifically because they were promised tax revenue and jobs. The trade is simple: cheap electricity in exchange for economic activity. What this means in practice: the grid absorbs the increased demand. The cost of that demand is distributed across all users of that grid. Across you. This is already happening in parts of Virginia, which hosts the highest concentration of data centers of any region on Earth. Residential electricity rates in Virginia have increased faster than the national average for 3 consecutive years. Utility companies cite infrastructure investment in their rate increase filings. Infrastructure investment meaning the cost of building the power capacity to serve data centers, paid for by residents. There's a version of this story that ends well. Amazon, Microsoft, and Google have all made commitments to power their data centers with renewable energy. Microsoft has reactivated the 3 Mile Island nuclear plant specifically to power its AI infrastructure. If the energy transition keeps pace with AI demand, the grid strain could be managed. The problem is the word if. Current projections show AI energy demand growing faster than renewable capacity is being built. The gap between those two lines is your electricity bill. Here's what this means for you, not in theory, but in the next 3 to 5 years. If you live in the United States, the UK, Canada, or Australia, you are connected to a grid that is being restructured around AI demand. Your utility provider is already planning rate increases to fund infrastructure expansion. Those increases will not be labeled AI surcharge. They will be labeled infrastructure investment or grid modernization. The companies building this infrastructure will not pay the full cost. The negotiating power of a company committing $200 billion to a region is not comparable to the negotiating power of a residential customer. You are not at that table. What you can do is understand what is happening before it happens. The regions that will manage this best are those that diversify their energy sources fastest. The individuals who will be least affected are those who reduce their dependence on grid electricity, solar efficiency, storage. This is not an environmental argument, it is a financial one. The AI energy ceiling is real, and it is coming for your bill whether you think about AI or not. Every major technology transition in history transferred costs to ordinary people. The railroad era, the automobile era, the internet era. AI is no different. The only question is whether you understand what is happening while it is still early enough to matter. If that is the kind of content you want to understand before everyone else does, subscribe.